If you can hear me, see me, quickly let us know your introductions on the chat. Let us know which part of the country you're joining us from. Great, thanks. Thanks for that confirmation of reaction. Great. Just if you can also introduce yourselves. My name is Aparna. I'm going to be your host for today. We've got professors from IIT Bombay. We've got a host of panelists today going to take you through the session. Yeah, put your introductions on the chat box. We've enabled the chat. This is how we're going to go about. Let's say, put your name and your city. So I'm Aparna. I'm going to be the host. I'm streaming from Bangalore. Thank you, Kashif, for that. The others also, it'll help. Just know us, know each other a little better. Vinod, hi. Suraj, hi. Abhinav, good to have you. Sudeep, great to have you. Yes. Priya, Kolkata, Shubham, Dhananjay, Ayub. Nice. Akhil. Hi, Saurav. Amazing. Hello, Karthik. Great. Sharat, Kumar. Great, Pankaj. Nice to have you as well. A lot of people from Bangalore, interesting. Great. It's nice to see all of you on a Monday evening, right? Joining us for this session. We are all gathered here to understand about the IIT Bombay ePGD in IC design in practice. And like I said, we've got professors from IIT Bombay who are going to take you through what this course highlights, what this course is all about. And towards the end, we'll also help you understand the enrollment steps, right? So it's going to go over for about hour to hour and a half. And you may have questions for the panelists. So make sure you use the Q&A box specifically for questions. And let's say we've got interactions during the session. Let's say we ask you something during the session, make sure you put it on the chat box. But otherwise, there's a separate Q&A box which you can use to put in your questions, and we'll compile all these questions and ask the panelists towards the end. Okay. Now, once you've posted the question, please make sure you don't post it again. Just makes it repetitive. And what I'm also going to do is, I'm going to keep the questions public. So anyone who posts a question is exactly visible to anyone else, the other attendees as well. Yeah. All right. So are these ground rules clear? You know what to do. The chat box and the Q&A box, maybe a quick thumbs up or a yes on the chat will help before we get started. Yeah, Shreya, great. Sunny, Arushi. Great. Pankaj. Everyone else, a thumbs up will help. Yeah. Okay, amazing. Great. Thank you, Sunny, for that introduction as well. Praveen, all of you are clear, right? So you can put your questions at the Q&A box. We will address them towards the end. And we're also going to be interacting a lot on the chat box. Now, speaking of interactions, just some more information that we would like to know from you is, where are you in your semiconductor career journey? Okay, now you can let me know this answer on the chat. So professors are also aware of who the audience is, right? So quickly let me know your answer. You can be a final year student. You can just be starting out in your career as a semiconductor engineer. You are already an experienced professional, or you're working in a related field. Whatever your answer is, 1, 2, 3, or 4, that'll help. Easier to type. Yeah, great. Shreya, you're a fresher. Abhinav, you work in a related field. It's amazing. Asha, you're a physics graduate. Okay, you're experienced but new to this domain. Fresher. Someone is an RTA design engineer for 9 years. Okay, interesting. Working as an electrical maintenance engineer. Physics graduate again. Okay, starting your career. Pritish. Dhananjay is an IT support engineer. Okay, MTech first year. Okay, experienced and working in related field. Ekta. Great. Sunny is a fresher. Anyone else? Yeah, Pritish. Great. Thank you so much for those responses. This was really helpful. So with that, let me introduce our panelists to you. We've got Professor Usha Ananthakumar, who's the Dean of Education Outreach, Professor of Decision Sciences at SJMSOM, IIT Bombay. We've got Professor Anil, who is Green Energy and Sustainability Chair Professor, Department of Electrical Engineering. We've got Professor Lakshmi Shah, who is Assistant Professor, Electrical Engineering at IIT Bombay. We've got Professor D.K. Sharma, who's Professor Emeritus at IIT Bombay. We've got Professor Maryam, who's also part of Electrical Engineering Department at IIT Bombay. And we've got Kashyap, who is the co-founder and CEO of Simplilearn. So I think, Kashyap, I'll just hand it over to you here, just do a quick round of introductions and then we jump right in.
Thanks, Aparna. Hi, everyone. It's a pleasure to be here and welcome all of you to this webinar around ePGD program in IC design. This is very special to me from both perspectives as a co-founder of Simplilearn as well as an alumni of IIT Bombay. I graduated from BTech in 2002. So delighted to partner to lead this partnership between Simplilearn and IIT Bombay. I think all of you are here, I'm sure, to hear from all the faculty members at IIT Bombay. So without further ado, I think let me hand over to Professor Usha, who will start off the proceedings. So Professor Usha, over to you.
Thank you.
I think, Aparna, we can move to the next slide.
Yeah.
Thank you all. Good evening, all of you. Let me welcome all of you to this webinar of ePGD in IC Design on behalf of IIT Bombay. Educational outreach at IIT Bombay aims to provide access to high-quality IIT Bombay education to a larger audience with a mission to provide access to education globally. Our focus areas are in designing industry-relevant programs for working professionals. We also offer rigorous and diverse upskilling opportunities for professionals across industries, academia, and governance. Currently, we offer a wide range of courses and programs. One is Postgraduate Diploma, for which we've assembled today. Other programs include our continuing education program, which we call it a CEP, on various emerging topics. We offer both as open as well as tailored in-house courses for organizations as well as academic institutions. We also offer, specific programs to our own alumni on various emerging topics. And the other thing which we take care of is NPTEL courses, which are being offered through SWIME platform. I mean, I suppose you must be knowing about NPTEL. It's a joint venture of IITs and IICs, providing the world's largest online repository of courses in engineering, basic sciences, humanities and social sciences, management, design, etc. Now, this ePGD, which we call as Postgraduate Diploma, the model works like this. It's a very flexible program, which is made up of a stack of courses, which one has to do to be eligible for ePGD. So anyway, there people will be talking about various features, but let me just talk about the important characteristics of an ePGD. This is an online 6-course curriculum designed for both working professionals and fresh graduates, where you can earn IIT Bombay credits. Typically, it's made up of 6 courses of 6 credits each, which makes it 36 credits, where you can save these credits in academic bank of credits, which we call as ABC. And the other features include in-person graduation and certain alumni status, which comes along with this for this ePGD. This also provides lateral hiring group facility where, one can add your email ID to this informal group to receive updates on employment opportunities from recruiting companies. So these are some of the features of this ePGD. So let me again welcome all of you to this webinar. And now let me hand it over to the host for taking it further. Yeah, hope you'll have an interesting session here. Yeah, absolutely. Thank you so much.
Thank you, Professor Usha, for that introduction. Professor Maryam, if you can take over and help the learners understand why this ePGD is relevant.
Sure. Good evening, everyone. It's my pleasure to be with all of you in this session today for the first time. So The first motivation started from a document which was prepared by IIT Bombay around more than 2 years ago. And that was about the landscape of the workforce development for semiconductor industry, along with the mission of the government of India for the semiconductor. And here you see some of the numbers you can read. And this is not only for the India, but it's also for the global perspective. The reason is because across the all countries, I would say that this has become now a matter of attention. This is a very important industry with a wide range of the subdomains. It starts from materials and ends at the electronic systems for diverse set of applications. Almost any application you look will have it. And this is where you can have in this slide some of the examples. I'm sure that you are already familiar with some of the examples, but all of them effectively nail down to one important module, and that's integrated circuit. Integrated circuits are found in all electronic systems. Therefore, focus of this program is not about system itself, it's more about the ICs available in that system. I am sure almost like all of you, at some stage of your career or education have come up across various commercial ICs, you have prototyped something, and you have learned how to work with electronic systems, which have many of those ICs. Now, specifically, we want to focus on the IC design and specifically for the education in this domain, which will take you to various types of applications. For example, would you please be on the same slide, moderator?
Sorry, Professor. Just, yeah.
Previous slide. Yes. So analog and mixed signal ICs, RF ICs, digital ICs, and at the end of the day, we have system on chip, which will make the whole system to actually shrink and come on the same chip. Now, it is very important to know that how we can extend the level of education and reach to the wider range of the learners like you, so that you can also get benefited from this domain knowledge. Okay, now next slide. So as Professor Usha mentioned, so the courses, as Professor Usha mentioned, the courses specific for ePGD. Sorry, these slides are moving.
Yeah, I'm so sorry.
Moderator.
I think it was just an error. I'm so sorry. I'll just reshare my screen. I think they're just autoplay. I'm so sorry.
Maybe you can keep it on manual mode.
Yeah. Yeah, I'm just resharing the slide again. I'm so
Sure.
sorry, Manas and Professor.
No problem.
Yeah.
Okay. So as Professor Usha mentioned, so this is a collection of courses, and eventually you will get the IIT Bombay credits, which will be saved in the academic bank of credits, and you can have it as a certified credit with you. And when after completion of the 6 courses, you actually will get the certificate with respect to the completion of the ePGD, and that's the ePGD certificate. And graduation and will be in person, and you will get also access to the a Google group of lateral hiring at IIT Bombay, which will give you the opportunities to receive the available positions and job posts which come from the placement office. So it will not be directly with placement office, but it is a lateral hiring group. And this is very helpful for you if you are looking at the various job options also after you have completed the ePGD. So next slide. Yeah, so this IC design in practice, we have tried to cover a wide range of the courses, And the courses are divided into two parts. Sorry, it's moving again. So next slide.
Yeah, okay. I think my cursor is the problem. I've realized that. But yeah, I'll just make
Yeah,
sure.
so,
Yeah, yeah.
okay. So we want to start from the devices. And this is very important to know that which devices, because these devices also are undergoing the progress and advances in the technology. So it's very important. And then find a foundation in the basics, analog and digital IC design, starting from first principles. It's very important. So it's about learning these fundamentals so that you will become a designer at the end of the courses. So therefore, it's very important, these fundamentals, to be strong. And make sure that, I can assure that these are very important and very much will be with you till end of your career. And knowing fundamentals never will be replaced by AI. The reason is because unless we are not, our own natural intelligence is not bound to the fundamentals, we won't be able to get assistance from AI. So this is important to know that, because this comes at the beginning and core course, which is mandatory for every learner. Sorry, again, it's moving.
Okay, I think it's just a problem with my cursor. I've requested, my team to open up the.
Would you like me to share? I think I can share it from.
Yeah, that would be helpful, because this,
Sure.
I'm so sorry, my system is acting up today. It does not happen. Yeah. I'm just allowing you to screen share.
So as slides are getting ready, one more reason for fundamental courses, two core courses, is that there is a diverse background of the learners, and to be compatible with everybody, these core courses are mandatory, these two core courses. However, those who already have experience will be able to finish them quickly, and those who don't is okay, so they can learn it very well over a time. So next
Maryam,
slide.
am I on the right slide? Or?
No, next. Yeah, this one. Okay. Yes. And then we move to the elective courses, where you can take 4. And these courses cover gallium nitride devices to MMICs, all in gallium nitride technology. And the rest of the courses will be in CMOS technology. For example, RFIC design or SERDES systems and mixed signal design. You can move to the next slide. So now about eligibility criteria. So to cover almost all possible BTech degrees with a background in electronics, the eligibility is shown on the right side that we have considered. So any domain which has the electronics as a background in the BTech is eligible to apply to. Okay, next. So here is the structure of the program, which includes 2 core courses on the left, as explained before, and then electives on the right side. Of course, right now you see 5 electives because there are 5 electives, but 4 out of 5 will be enough to complete basket of 6 courses. A basket of 4 electives plus 2 core, which is 6 courses. So digital IC design and mixed signal IC design will be answered as IC design. These are eventually coming based on the pillars of digital and analog. And then we have 2 courses, which are again based on that pillars of digital and analog IC design, as well as semiconductor devices, which are gallium nitride, as well as RFIC. Of course, even in other courses, electives, we need to have the background in semiconductor devices, because it helps us to get a better idea about the approximate models which are used for the other domains of IC design, any domain of IC design. Next slide. So we have a very nice group of faculty members who have come together and then are contributing to this set of courses for all of you to get acquainted with the knowledge and experience, to get the confidence and also training as well as confidence to complete a design from the beginning, specifications till end, which is very important in industry. Industry needs engineers who can take ownership. I mentioned this sentence based on the inputs we have received from industry. And to get the confidence in ownership of the designs, it's very important to take you through the entire procedure of the design. So we have faculty members, Professor Pradeep Nair, Professor Anil KG, Professor Saurabh Lodha, Sandeep Mondal, Professor Laxmi Shah, Professor Dinesh Sharma, who is Professor Emeritus of IIT Bombay, and Professor Dipankar, Professor Sorup Ganguly, Professor Apurva Bhattacharya, with experience work in ISRO, myself, as well as Professor Rahul Singh and Professor Shalabh Gupta and Professor Viresh Deshpande. So the contributions are completely depending on the nature of the course. Some of the courses, several faculty members are involved, like semiconductor devices. In some other courses, 2 or 3 faculty members are involved. And this will give you a better way of covering the various aspects of a given course. Next slide. So now here we will have course details, but we don't want to take a lot of time from you to explain each and every course, but based on the availability of the faculty here, so I request my colleagues to go ahead one by one with the devices. For here, Professor Anil KG will explain briefly about the content of the semiconductor devices, which is a core course. So over to you, Professor Anil.
Thank you, Professor Maryam. Hi, everyone. Good evening to all of you. So we have this semiconductor devices course. So this course will actually develop a detailed understanding of semiconductor devices that would range from the basics of semiconductor classical description and common electronic devices like diodes, MOSFETs, to current state-of-the-art CMOS devices. And we would also discuss the techniques and concepts associated with the fabrication of integrated circuits. And also we would be talking about emerging materials like 2D materials and devices. And a very important aspect is the reliability of electronic devices. So the hope is that this would give you a strong foundation to build your design understanding. Thank you.
Thank you, Professor Anil. So we lost the screen. Would you please share it again?
Yeah, I'm just sharing it once again. Is my screen visible? Am I? Yeah.
Yes.
Yeah. Okay. Great.
Okay. So next, slide 20. So I request Professor Laxmi Shah, who is the instructor for this course along with Professor Sharma, to give a brief description.
Hi, hope I'm audible. Good evening, everyone.
Yes.
So pillars of digital and analog IC design is one of the core courses being covered by Professor Sharma and myself. So we will basically, this course is going to be the background for the elective courses that that are going to take in the successive terms, and you will start from sort of device physics, layer of abstractions that is required to intuitively understand workings and design of fundamental blocks, uh, basically in both analog and digital ICs. As the course progresses, so you'll also see that how these abstraction layers help you weed out some of the workings that is not important and retain some of the things that is important, so that design rules become easier to handle. We'll also slightly delve into analysis because again, as was mentioned earlier, first principles are very important, and coupled with the mathematical analysis is where you can intuitively have a good feel about your designs. Uh, yeah, so that's all. Professor Sharma can add more.
No, Lakshmisha, this covers most of the contents of this. I am also looking forward to this course and teaching it in this mode. So welcome to you all.
Thank you, Professor Sharma. It's a privilege to have you, really. Okay, so then we can move to the next slide. Yeah, so digital IC design. So again, back to Professor Lakshmisha and also any input from Professor Sharma. Yeah, please go ahead.
Yeah, thanks. So building up on the first principles from your pillars course, so the digital IC design will delve more into conceptual understanding and design verification concepts of any digital chip, a model digital chip, and we'll have good hands-on feel about it as well, in the sense that you'll have simultaneous theory plus hands-on experiences at different layers of abstractions, which is very important. You will take concepts of bottom up approach, which has been followed up in the industries in the sense of developing standards and libraries, IO libraries, SRAMs, which are the basic building blocks of any of your modern digital chips. We'll see how using different abstraction views of these such libraries you can build bigger and bigger chips, and what are some of the constraints that you have to keep in mind while designing these chips. So what are the different trade-offs associated, and so on and so forth. So hopefully with this course we'll try to give you a good hands-on approach of designing a digital chip end to end, starting from a device understanding all the way up to a bigger chip, again with hands-on and simultaneously a good intuitive feel about it. Thanks.
Thank you, Professor Lakshmisha. Next slide.
Professor Maryam, would you like to highlight?
Next slide. Yes. Okay, so this is about gallium nitride. Okay, yeah, this is the course that I will be teaching along with Professor Sharma again. So therefore, both of us will talk about it. So as name shows, and you may be familiar as well, that is where we are looking at the blocks which are integrating analog and digital signals together. And there are variety of the blocks which are mixed signal, and their design needs a different approach, not exactly the same approach which is used in fully analog or fully digital circuits. And that's why they formed a separate category of the integrated circuits. So for example, if you look at the sampling circuits, so there is a clock which is coming from a digital source while the input signal are analog. So therefore we have a switch which will be more like an analog switch while it's controlled with a digital signal. Sometimes we need to change that digital signal, and therefore it becomes a combination of digital and analog. Similarly, we may do the discrete time processing instead of continuous time, and then have the modules which takes us completely from analog to digital domain or digital to analog domain, and then they are doing this function with the precision, speed, power, area, and other requirements that will be needed according to the target specifications of the chip that this module should sit on it and then should work. Then we will also have various other modules, for example, phase lock loops, or for example, all digital phase lock loops for the frequency synthesizers and various other applications. For example, for ADPLL for the automotive applications. And we will also use ETL tools because we need to learn also how the entire flow from specifications to the layout is established here, considering it's a mixed signal, and therefore the final layout will have both analog and digital. How to manage this both analog and digital design together through the entire process, starting from system level modeling down to the layout. And these are examples that we right now specified for you, but there are other courses as electives as well. So if Professor Sharma, you would like to add anything to this part, please.
Yeah, this is good. I see one of the comments on the thing about simulation. So the course and the duration that we have, most of the work will be on simulation and simulation tools. And the part that I will cover, I would like to use public domain tools for which you don't need license and you can install on your computers and run the simulations on those. And mixed signal design is a very exciting course actually, because very often the digital part runs at a very high frequency. The analog signal is at a low frequency, and the simulation of both of these simultaneously presents challenges which are very interesting to conquer, and we are looking forward to discussing all these issues in the course.
Thank you, Professor Sharma. This is
and in answer to
yes,
one
please.
of the comments, indeed, these tools work primarily with Linux, though Windows versions are available, but they work primarily with Linux, the public domain tools.
Thank you, Professor Sharma. This was important, both points that you mentioned. In fact, to continue based on what you said is that there will be two sets of tools. In fact, these courses will be based on two sets of tools. One is the open source tools. And as Professor Sharma mentioned, it's very important to learn also how to use open source tools, because you know that there are initiatives for the IC design based on open source tools in India and globally. Therefore, we want really you to get that experience, how to use open source tools. Along with that, also, we are talking to the commercial EDA tool providers for the support on the ePGD, and that will give you also the experience of using commercial tools, specifically for the elective courses, because that is where you will get into the complete design flow for the various applications and various domains as divided across courses. This is also compatible with the questions Professor Sharma mentioned you have said. Therefore, we will have the beauty of, in fact, this ePGD courses, this set of ePGD courses is that we will cover both type of tools. And to add, it's not tool which will define you at the end as an experienced, confident engineer. It's about the knowledge and the skills and the capability of the analysis and intuition that will define you. And that's very important. And how to deal with complex problems, taking help from tools, any tool is absolutely fine, but still there is a driving mind, which is your mind behind everything. Yeah. So now we can move to the other slides. So RFIC design, which will be taught by Professor Rahul Singh. And if you have any question specific with respect to this course, you can write in Q&A, and then I will transfer the questions to him, and the answers will be posted. So he's not available today, but it's similar to mixed signal, but in RF domain, and therefore naturally everything will be high frequency. This is where you will need mainly commercial tools. Some basic EDA tools may be used, but You will need, because they need a very precise modeling and incorporation of the layout precisely right from the beginning. Next. Yeah, certain systems will be taught by Professor Shalab, who is actually working in this area for many years, and he will tell you about that, how data is transmitted, sent over physical, eventually channels across different systems in computing and for other applications, both computing and communication applications. So again, if you have more questions about this course, you can type your questions in the Q&A, and they will be sent to Professor Shalab to answer in a, and then you will be informed about that. But what is important is that these courses you will take based on your interest and based on your plans. We don't have too many electives right now because you know that the faculty members have their own department load, and they are also offering these courses in addition. And therefore, we have, as of now, enough number of well-selected courses which are compatible with their industry requirements, and therefore you would be able to choose 4 out of 5 and proceed further. Next. Yeah, so for the gallium nitride course also, which covers device to MMIC, and it's a very interesting course which has everything inside because gallium nitride devices are different. We will have we have this course because we want to give opportunity to those who would like to learn gallium nitride as another technology which is important for the very high frequency as well as high power applications. And here the focus will be, of course, on MMIC, monolithic microwave integrated circuits. Okay, and this slide shows a kind of glimpse of the certificate which will be given at the end to you with the and issued by IIT Bombay. And this is eventually will be a diploma in IC design from IIT Bombay, postgraduate diploma, of course. So because all of you will have the minimum BTech degree already. Next. Yeah, so that's as an alternate option, just some of you may want to know, is that in case you are not interested in taking all 6 courses and therefore you are not interested in the ePGD certificate, you can choose to take a subset of these courses, means 1 to 5 courses, and in any manner, except of course, core courses still have to be taken first. And therefore, you will receive the certificates and the certificate of credit from IIT Bombay, but the ePGD degree will, ePGD certificate will not be given because the whole set of courses is not completed. So it's up to you. As per my early interaction with some randomly selected candidates, was most of them are interested to complete 6 courses. And their motivation is to get the ePGD diploma. Yes. But this is also for your information. Okay, next. So
yes,
yeah.
I think Dinesh would take over here.
Sure.
Dinesh, you can highlight the application process and the fee structure.
Sure. Thanks, Aparna. Good evening, everyone. So I'll quickly run through the steps to register for this particular courses and the ePGD. The step 1 is you have to submit the application. Along with that, you have to submit your 10th standard and 12th standard mark sheets and graduation mark sheet and the CV. CV is mandatory, and all these documents will be forwarded to the panel from IIT Bombay, and your profile will be reviewed and the final selection will be communicated to us. And it can be direct selection, or there can be a small interaction with any of the faculties who is part of this ePGD. And once we receive the final confirmation, so then we will be rolling out the provisional offer for registration, and the candidates can register for the term, which they are going to start immediately. And I will just quickly cover the fee structure for this ePGD. So once the provisional offer for registration is rolled out, so the learners can pay the registration fees, which is 45,000 rupees plus GST. And for term one, there will be 2 mandatory courses, and that will be each be priced at 52,500 plus GST. So all the courses are priced at 52,500 plus GST, and based on the comfort level of the learner, so they can take the number of courses they want in each term. But as Professor communicated earlier, the first term mandatory courses should be taken, the 2, and third courses, if someone has to take the third course, they have to get the approval from the panel from IIT Bombay. So that's how the fee structure works. And
Sorry, Dinesh, sorry I interrupt. I thought it would be nice to add, in fact, what you mentioned to
Yeah.
justify. So the main reason for this is that many of you may, for all of you, in fact, this will be new. Therefore, when you enter the first term, it would be better not to overload yourself. This is advice we also give to our own students, regular students. So therefore, and because most of you are working. Therefore, that's why after reviewing your CV and your mark sheets and overall, then we would be able to really tell whether it is okay to take 3 courses or not, because the quality of the content, we don't want to be compromised. And therefore, when you take 2 courses in the first semester, you will get the foundation, and then in the next semester, next term, you would be able to get electives that you would like to take. And that would be better for you. That's the technical reason for this. Otherwise, you are okay to take even 3 courses, but in the first term. But consider that you may not have enough time and bandwidth, and also it may overload you unnecessarily. So, and it will not have a significant impact on the whole duration of the this 1 course difference will not have even 2 courses difference will not have a significant impact on the duration. Yeah, back
Sure.
to you.
Thanks for the clarity, Professor. For someone to be eligible for the ePGD and complete 6 course, so the total fee will be coming around 3,60,000 plus GST. And so whenever you are interested, you can reach out to our counselor, so they will be able to help you with the right financial options. And this immediate term, the registration will be closing on 22nd August. And Aparna, maybe you can move to the next slide. Yeah, so this is the first cohort details. The induction will be, the registration will be closed on 22nd August, and the same day induction will be happening. And the regular classes will be starting for the term 1 from 30th August, and this will be completed by 10th December 2025. And end semester exams will be in-person exams, where it will be conducted in IIT Bombay, and the exact dates for the exams will be conveyed later over the course of the time. And there'll be live interactive sessions as part of each course, and that will be conducted outside the office hours over the weekend, and that live classes will be taken by the respective professors. So that's at a high level on the cohort details.
Thank you. Thank you, Dinesh. Thank you, Dinesh, for enlightening the learners about the enrollment steps and the fees. Kashyap, if you can just have a few words on what Simplilearn is all about.
Sure. Yeah, we can move to the next slide. So hi, everyone. I'll cover briefly a little bit about Simplilearn. As we discussed at the start, Simplilearn has partnered with IIT Bombay to make this ePGD available to everyone, and we are delighted with this partnership. So Simplilearn started about 15 years back. I think our vision has always been about transforming lives by helping them get ready for skills for the future. And I think in that context, I think Professor Maryam captured it really well, that, semiconductors is a space where there's a lot of action happening the news as much as AI is. So there's a lot of action happening here. So very timely program for most of the people expressing interest in this area. We over the years have had the privilege of being able to impact 8 million plus careers and have 50 plus global partnerships of academic institutions and companies that we work with to offer various programs. Yeah, we can move to the next slide. So in the Indian context, on the technology side, we partner with IIT Bombay and with many other IITs to offer programs in various technologies. We also partner with a lot of the large corporates to co-curate and co-create curriculum around various technologies. And in the US context, we partner with universities like UMich, Purdue, Virginia Tech, and so on. The focus is always to build programs that can help people advance their careers. So things that we are proud of, I think the 4.8 on 5 rating that we receive from our learners for the various programs that we deliver, high graduation rates, as well as finally career outcomes. So that's very quick summary about Simplilearn. I think we can move forward. I see a lot of questions around the course duration and various aspects of it. So we can move to Q&A where we can try and take all these questions and give all of you more clarity.
Absolutely, absolutely. Thanks, Kashyap. Thank you, professors, for enlightening us about this course. So I think I'll just pass on a few questions that we received on the Q&A box. Some of them were addressed while we were talking about each modules. So we have a question from Pradhan who says, how to evaluate design in real time with the latency and complexity along with functions? So will there be hands-on FPGA kit for implementing the design and also evaluate it? That's one question that we have from Pradhan.
Okay, I can answer this question. Of course, Professor Laxmisha and Professor Sharma can add to that. See, this course is focused on IC design. Therefore, it's not about FPGA-based design. So there will not be any hands-on on FPGA-based design. Everything will be IC design. In fact, name of all courses somehow has something about IC design. And the main reason is to make the program focused. And and all courses are focused, in fact. So now each course has its own assignments, could have quiz, will have project, and these are all dependent on the instructor or group of instructors who are teaching that course. Therefore, as I told you, it comes with the practice and practical assignments and practical design project. That is the skill which is a target of this set of courses to be established in you. And we will not have any FPGA-based and hands-on debate. So you will learn how to work with the tools, you will learn how to start from fundamentals, and you will see that a lot of that will come from understanding of the fundamentals and moving further to the modeling of the systems on the chip. And then how from these systems and modules, you will be able to do a hierarchical design. So that perspective of the design flow is very important in IC industry. So that is the focus of the course.
Great. Arun, I hope that answers your question. Professor Maryam or any other professor, you can take this question. So Aishwarya is a BSc Physics graduate, and she wants to know if she's eligible for this course. And of course, we talked about the course duration, but I think she just wants to understand her eligibility and where she stands.
Okay. So actually, see, the main reason is because of it will be very difficult. Let's put it that way. It will be difficult for somebody who has the background in physics directly jump to IC design. See, if you have and you are able to get a BTech in any area which has components of the electronics, you will be in a better position to take these courses, because these courses are not completely in person, though there will be live lectures, but most of them are recorded. And therefore, if you want to it's just you are changing your domain completely. And therefore, many basic courses that the students with a BTech degree, which has electronics, for example, electronics and communication background, or for example, electrical engineering, or for example, electronics and instrumentation. So they have that base, and we don't need to teach that base. The core courses that we have, these are the core courses which are start of the IC design itself. And that is the main reason for not having physics graduate, because it would be difficult. It would be really difficult for the learners as well.
Got it.
That's the reason for that.
Got it, Professor Maryam. I think that was straightforward. And I think, Aishwarya, your question is, I hope your question is answered. Okay, I think I can stop my screen share right now because this is just creating confusion. Yeah, I'll just head on to more questions now. We've got another question. Will there be AI accelerator design in the digital design course?
Okay, maybe Professor Laxmisha will be able to answer.
Sure. Within the given time span, designing and complete a accelerator will not be the scope of the course. However, in the course project, we can discuss. So there is a possibility of designing a single thread core as part of the course project in the course. So, but then that would mean spending sufficient time on the course project. So, yes, possibility, but not a full-fledged one.
Got it.
In fact, based on Professor Laxmisha's response, I would like also to mention a little more kind of elaboration around this point. Course projects are entirely to the instructors as well as learners. In fact, the input right now regarding, say, for example, an accelerator design, AI accelerator design, which came to Professor Laxmisha. So it's eventually, if suppose there are interested learners who want to take project in a specific application domain or for a specific module to design, so instructor would be in a position to explore it, and actually based on what the learner likes to take the project on it to define the project. So therefore, if suppose this is an area that is of interest, and Professor Laxmisha, as he mentioned, there is enough bandwidth in the course itself. So maybe not the entire complete design, but a part of it can be defined as a project. In fact, all suggestions are most welcome. There will be an interactive session when suppose we want to decide about a course project with the learners. So those interactive sessions will help to fine-tune the project or projects. Yeah.
Got it. Thanks, Professor Maryam, for answering that in detail. We've got another question from Arun Pradhan. You also posted a question earlier. So how much will be computing or signal processing RTL design activity in digital design? How much of that will happen?
Okay, so this goes to Professor Lax.
So if I understand it right, how much percentage of?
Computing or signal processing and RTL design activity will happen in digital design.
Okay, understand.
Yeah.
So RTL design itself is not part of the course, but we will spend enough time, probably 5 to 10% of the time, on discussing some standards as to how do you write good RTL. But again, this is IC design, not RTL design. So the focus will be on, if I have written a good RTL, how do I properly take it up all the way up to a chip or an SoC. That is what is the problem statement. So yes, we will spend not significant amount of time on RTL, but you will definitely have some assignments on RTLs to get back your bearings on RTL design. But yes, the focus will be on from RTL, how do I go there, and what tools and what equipments do I need to have to go from RTL to the chip.
Got it.
Yeah.
Got it. Thank you.
Mixed signal design will also do signal processing partly.
Right. Yes, that is correct.
Yes, yes.
Okay, great. Thank you, professors, for highlighting that and clarifying another question. Again, I think this is about the tools. Another question about tools that Saurav has. What are the tools we'll be using during the course? All the EDA tools will be open source, or will we have access to the licensed ones as well from Cadence or Synopsys?
So we answered that question
Yeah.
already, right?
Yeah,
That
absolutely.
similar question was asked by one of the participants.
Correct.
I think
Correct.
same answer we have given is valid here.
Got it, Professor. Thank you. Thank you so much. Just another question about eligibility again. So we've got a student who is a bachelor's in computer science. Are they eligible to apply for this course as well?
So when similar to physics, more often, same answer I would say about computer science, because computer science graduates have the experience and knowledge about the, for example, softwares, various aspects, data flows, programming, but they have not touched really circuits. Now, there is one exception which could be valid also for the physics graduates. For example, they have a minor in the same degrees that we have mentioned. So that means that they have taken enough number of courses, which gives them the background. But if that doesn't exist, so the same difficulty will be for the learner himself or herself. So the problem would be that we assume that some of the concepts which are taught during BTech, specifically second and third years, even fourth year, so they are known to the participants, and that's why we start from the next level. And for the graduates who are not having background in any kind of device and circuit, so it will not be very straightforward, and the quality will not be compromised, so it would be difficult. We would like really the learners to start from the point that they have a BTech. They are called BTech in electrical engineering or electronics and communication. So, but if you have a minor in that minor in your degree mentions that you have the minor, so then it becomes a kind of having that set of courses, and then we can look at the set of courses you have taken and then take a decision. But in general, will not be will be same as physics. Yes.
Understood, Professor. I think that also clarifies to all the other learners who have similar questions on eligibility. I hope this answers. So yeah, I think that's it. So we've got just one more question on the scope of employment post completion of the course. So how does one, or what kind of roles can one really take up after this course is complete?
See, if suppose you take all courses, all 6 courses, and then 4 electives plus 2 courses, and you perform well. Perform well really is not measured by the numbers. Perform well means that you have got the gist of the content. You have really become strong in when you look at a problem of IC design in any domain, let's say a digital circuit or analog or mixed signal or RF. So you know that how to start and how to end it. You know how to model it to at the system level, how to even at the circuit level create some abstractions and then analyze it. Look at the constraints and trade-off between the specifications. If you have all this experience plus having done a course project by yourself completely, so that potentially naturally makes you a person who will have the requirements of the being absorbed by industry, considering you already have BTech and this ePGD. But we are not a part of that placement or a part of the, job creation but definitely there will be some kind of support, as Dr. Sotadru and the EO faculty in charge mentioned, Professor Usha. So this group lateral hiring will help you to get opportunities, which is also getting connected to companies who have an industry, who have positions. So I can say from this angle. So we will not be in a position to say exactly where, but I'm sure that in the domain of IC design, there are many startups, there are many MSMEs, and there are many Indian as well as the multinational companies. So therefore, scope, in fact, one thing I can tell you even today, based on the inputs we receive and based on what we see also everywhere in industry, there is demand for good IC designers. If you become a good in the sense that a capable IC designer, you will be on demand. You will not remain jobless. That much I can tell you.
Got it. Great. Great. Thank you so much, Professor Maryam and Professor Dinesh, Professor Lakshmi Shah, Professor Anil, Professor Usha, of course.
Sorry, Aparna, sorry, I am interrupting you. I noticed that some participants have written the questions in the chat box rather than Q&A box. So
Yeah,
maybe you can have a quick look if we are not missing.
Yes, I am actually taking a look. Some of them have actually, they posted it on the Q&A box. But one such question that I think you already addressed was from Pritish, who asked this question about the knowledge network, the journals, and the lectures. So would they be available to the learners as well? So knowledge bank of the professors, would they be available to the learners?
Okay, so what is the knowledge bank exactly? What is that?
I think the learner is trying to talk about learning resources that would be used in the course, that would be given as a part of handouts in the course. I think that's what the learner is asking. But maybe Pritish, if you can just maybe repost your question and put it on the Q&A box that we don't mess it up. Yeah. And yeah, I think.
Okay, maybe I can give a comment here. Say, the same way that for regular courses, we have some references. So here also in the courses, there will be some references. However, the instructors will tell you which part to focus. So I can tell you one kind of generic rule. When a focus of set of courses is IC design, you need to be you need to learn from doing things. This is not only about a theory course, it's more about learning by doing. So therefore, first you learn how to analyze a circuit. Therefore, you don't need to read a lot around that. You need to do it. And therefore, the very important thing is that only focus on the content of the lectures. That's very important, content of the lectures. Don't get around to find too many things related to the content that will unnecessarily divert you and take your time. Instead, you spend time on the content and the references which are given for that. And if required to have, and will be, some tutorials, there will be some, for example, sessions which are solving the assignments for you. If you learn from them, that would be much better compared to studying too many things. Because at the end of the day, it's not about adding to the knowledge. It's more about that getting a knowledge which you can apply. Therefore, you are going to learn IC design, and therefore you learn whatever you learn in the lectures and the activities around lectures with a very much focused content of the references. That would be enough.
Can I say something about it?
Sure.
Yeah.
Professor.
So this is Anil. I think the participant has asked about resources and access to them, right? So IIT Bombay has several resources. Library is, of course, one of them, through which they could potentially access digital books and also journals and so on and so forth, if they are referred to in the course content. So this is, I think the EO, the education outreach representatives could clarify whether the postgraduate diploma students would have access to the library resources.
So I'll take that question, Professor. Thank you. So regarding once, I mean, they are registered for the courses, they won't be provided any library resources, but once a student completes the 36 credits, they will gain the alumni status, and then they can get the library access, but not during the course. As of now, we do not have that framework.
Okay, maybe I can add one comment here based on Professor Anil and Dr. Satadur's comments. See, one thing is that instructor can provide some resources for the participants after consultation with EO office. For example, suppose, for example, a paper is used as a reference. So that some copies of that paper, some parts of that paper may be shared. I'm not still very sure about it, but that can be done instead of, for example, because for our own, for example, students also, we do that. So we need to discuss with EO office to understand that better. Otherwise, we will convert it to some content, which is only a subset of even that paper and shared with the with the participants. I don't think sharing a paper with a limited group of people is a problem. Should not be, in my opinion. Because that is with limited paper, any copyright and any publisher has, because see, people send papers to each other, right? It's a limited number of people. Yeah. If I make it in public domain, I'm not allowed because it has copyright. So these resources which are used for the project should be okay. About textbooks, I don't know. One option again would be some parts of textbooks can be made available, like for example, some section of a chapter. So it will be very limited, not the entire textbook, which is not required anyway. So maybe I can have more discussion with your office, but one thing I want to assure the learners is that you will not be left on your own to find out resources and then come back to the assignments and activities of the course. That definitely there will be enough support from TAs, from instructor, specifically from TAs who will handle the activities like assignment and project management for you. So that should not be a problem. Resources at a limited volume will be definitely available. What you need, we will provide.
Got it. Thanks so much, Professor. Just a follow-on question to the EDA tools. I know you talked about that, but a learner wants to understand if you can just name some of the EDA tools that are publicly available, which are used in this course. This learner Saurav and Sharath actually they had this question.
Yeah.
Professor Sharma has answered that question in the chat box.
Oh, okay. Yeah. Yeah, I think Professor Dinesh has already answered that, learners. Great. So there's one more question, professors. What type of board design are we making? Is FPGA or ACIC? So the question here was, which type of board design are we making? FPGA or ACIC?
I don't know, maybe I can take it. I think the course itself is not about board design, but about the chip design. So somehow, I don't think we can answer that question because.
Sure.
Yeah, I mean, it's more about chip design and
Understood.
working of a chip, right? I mean, not about a board. So
Yes. Yeah, Professor Lakshmisha is right. So it's not about board design. Courses are not about board design.
Yeah.
By the way, Professor Sharma also has mentioned about courses. For example, NG-SPICE for circuit simulation. Just I'm reading in case people don't write. GHDL and iVerilog for VHDL and Verilog simulation and so on.
Got it. Okay. So a student, Arun, who had a question earlier as well, is unable to understand the difference between digital IC design and RTL. I thought RTL is a part of digital design as front end of design. Can you please explain this?
Yeah, Professor Lakshmisha. You are muted. Professor Lakshmisha, can you hear us?
Sorry, I think I lost you. What was the question again?
The question was, so this learner is unable to understand the difference between digital IC design and RTL design. I thought RTL design is a part of digital IC design as front end of the design.
So,
Can you
got
please
it.
explain?
Understood. So, RTL design by in itself will have some bearings on your HDL concepts, which is your hardware description language concepts. And then synthesis will cover some aspects of converting this HDL to RTL, but it has minimal things to do with actual RTL design, but rather more on the synthesis tool itself and the underlying standards and library. So, if I can answer it precisely, we would be discussing about the hardware description languages, but not in a detailed fashion, because then that would boil down to HDL codes. But we will discuss about synthesis, how this HDL can be converted to RTL. But again, the importance is not going to be on how to write an HDL, but we will discuss good practices for HDL for synthesizable RTL generation. I hope that is clear.
I hope that clarifies, Arun. Okay, great.
Yeah,
Thank you.
just to add,
Mhm.
as you correctly say, RTL is part of digital design, but digital design has many other aspects that RTL doesn't look at. For example, sizing of gates, optimization of delays, and so on. So RTL is largely about using existing libraries to produce the functionality that you need. But for custom design and for even mixed signal design, RTL will not be the appropriate way to go about design.
Got it.
Thank you, Professor Lakshmisha and Professor Sharma. Really well explained.
Yeah. Thank you, professors. Just one more question. I know this is dependent on the courses that they take, but a learner, Kuldeep, has this question about how long is the duration of the course? Let's assume that in a week, will we be covering how do the terms span out? How does the entire duration of the course?
So I will answer this question. So in general, we would like to have every course kind of synchronized with IIT Bombay calendar. Only the first term this time will start around 1 month later because of because it is the first cohort and the first time, so logistics. Now, but that's why we will extend it to December. So if you go that way, so practically it would be nice if you have followed 2 lectures per week. So these lectures, many of them are pre-recorded. Therefore, they will be available to you in asynchronous mode. That means anytime you can watch them. But there will be some interactive sessions. There will be, say, for example, tutorials, which could be conducted by instructor or TS. Therefore, they will be, at the beginning, will be set. The timing for that, the time slot and the dates will be set with the corresponding participants in that particular course. So it's not fixed, it depends, but there will be a kind of regular pattern so that there will be a stream of watching courses, attending the online interactions, for example, attending a tutorial and so on. So this will be streamlined over a term, the same way you have had, say, during your BTech, you have an idea of how to take a course and do. So we try to do it that way so that it will be distributed over 1 term. Otherwise, the content will be too packed if it is covered in 1 month, and it will be very compressed and will not create efficiency in learning and doing the course project over time or doing assignments the way you will get that confidence of doing design by yourself. So our objective is you get that confidence and that capability and knowledge and the skill to analyze learn, analyze, and design. And therefore, for that, you need enough time. So on average, it is effectively equivalent of 2 lectures per week,
Okay. Yeah,
roughly.
I think that's what was the next question as well. How many hours of live classes happen on weekends, and how many of these sessions will be doubt clearing sessions, ma'am? So
Okay, that will be completely up to instructors. They will actually have one or maybe more than one sessions with you to design and then plan everything. It's up to the instructors, but definitely there will be interactive session by every instructor for every course to plan accordingly what would be the days during weekend or outside of office hours, and how many number of tutorials per week or every 2 weeks, and so on. So that will be according to the instructor. So they will talk to you
got it.
at the
Okay.
beginning of term.
Right. Saurav, I hope that answers your question as well. And maybe this learner again, I think, has a question about employment related and further opportunities. So he or she just wants to understand which companies we can apply for after they complete the
See,
school.
any company who needs IC designer, which is not also a small number, if you want to, even today at this moment, consider. So there are, in fact, you see a lot of, in fact, posts even that they need good IC designers, and therefore, I don't think you will have any difficulty in finding corresponding job, provided you really do well, and then you really focus on learning. You should focus on learning, not passing a course. Your motivation should be deep learning, really deep learning for natural intelligence, not for artificial intelligence. So if you do that way, and you do the assignments and projects with diligence and full dedication, you will be a person who will be on demand. That is what I can say. And all companies who have the requirements of the IC design, depending on the domain, will need you. Even there are companies who also need people who have some background about the devices and know the state-of-the-art devices, and that device course will give you that. So
Absolutely. Absolutely. I think you're right in pointing out about motivations that one should have. Thanks so much, Professor, again, for answering that. Just a couple of last questions, I think, after that, we will wrap up the session. So again, Arun has another question. Will there be HDL coding session for this? I'm assuming, and I didn't kind of understand what this was for, but he wants to understand if there's HDL coding session as well.
Yes, as part of assignments and tutorials.
Okay. Okay, Professor. Thank you. Another question is, what percentage of the lectures are live versus the recorded ones?
okay, this depends on the course, but at least I can say that for the maybe actually Professor Lakshmisha and Professor Anil are here, so they can talk about their course. I can talk about mixed signal course. So in mixed signal course, most of the lectures are recorded. Say, suppose we will have around 24 lectures. So around say 17 lectures will be recorded, and the rest will be live. 17, 18 maybe around, and the rest will be live. So therefore, and these live lectures plus interaction sessions as well. So they will help you to learn well. Advantage of recorded courses is that you can watch them several times and learn them well. When you watch, you also analyze them by yourself on pen and paper with pen. Pen and paper is the best way of learning design courses, IC design courses, and analysis of the basic equations, and then how to use device equations to come up with the models of the blocks, and then from models of the blocks, models of the systems, and then how to see the trade-offs. These are very important for becoming a successful IC designer. Yeah, so these are the typical numbers I can say about mixed signal course that Professor Sharma also teaching. For digital and device course, I request colleagues to comment.
Yeah, so for the device course, this is actually, you would definitely have lectures and online courses. In fact, online sessions. There are four colleagues who are sharing different aspects of this. And this would be mostly recorded lectures, but you would definitely get opportunities for interactions. And there would be several quizzes and assignments that should clarify the the concepts, and I'm not anticipating any simulation exercises in this because we do not go into so much depth. You can see the course, the particular course is actually dealing with four different topics. One part is the devices itself, and then we have technology that you would use for making those devices, and integration of them into ICs. And then you have a module on advanced devices. These are emerging devices. And then on reliability. So this is major four parts. And if you look at the curriculum, our master's curriculum in devices, this would be actually four different courses, right? So we do not have the bandwidth to go into the depth so that you can actually use simulations. One difficulty here is also that some of the or many of the complex device simulations are done using commercial software. So unfortunately, there are no easy to use freeware available for this purpose. I think we would refer to some of the resources in Nano Hub, which could be used for certain aspects. But then individual instructors would provide you the leads for that.
Got it. All right. Thank you. Thank you, Professor, for answering that.
And Professor Lakshmishan, if you would like also to mention. Or Professor Sharma.
Yeah, I think I lost the question is about percentage of simulation.
No, question is about number of lectures which are recorded and those which are live.
For the pillars course, which is one of the core courses, so Sharma and I will have probably 1/3 of the lectures as retraction live sessions combined, and the other 2/3 is recorded. Roughly, and for the digital design course, it will be fully recorded, but the assignments and there will be additional tutorial sessions that will be in person, but all the lectures will be recorded.
Okay, thank you.
Thank you.
Okay, I can quickly add the device part. So I'll be teaching you the reliability part of the courses, which would be recorded. But as Professor Anil mentioned, that actually the reliability course is like entire semester we are teaching over here. So, but I think we have very less bandwidth to teach that much of content in this course. So although the four or five lecture will be recorded, but out of this recording, I'll be directly interacting with you guys and see if we can again like extend the teaching part or the content part, which is beyond the course actually. If it is required, if people are interested, we can see that how it will be going to go. And the other part of the courses also, I think more than 50% will be recorded, and rest would be like in-person teaching. So that's the device area which I can add.
Thank you, Professor Sandeep. In fact, I would like to introduce Professor Sandeep is one of the instructors in the device course. And in fact, what interesting thing, as Professor Anil mentioned, they have done is that they have combined 4 courses of department, and they have created a new course which will fit very nicely this IC design course and provide all aspects of the devices which have to be on the IC, and reliability, emerging devices, and the fundamental CMOS technology, which will be a very valuable course for all of you, along with other courses. And that's why it's also a core course. Yeah, thank you, Professor Sandeep.
I'll add one more answer of the another question, which just before this question was there, like which company will be interested to hire you. It's this after doing this course, I think you will not only hired by the circuit design companies, it's like a device companies. There are different device companies starting from the memories and like who are preparing different architecture of the memories. So there they can hire. So there are very like lots of companies who are hiring the device physicist or device people. So they will be interested to hire you. So it's like a wide bandwidth you will get starting from the circuit and the device part as well.
Well, thank you, Professor Sandeep. Really nice. You brought another angle of the employment here. Very nice. Memory technology, memory companies. Yeah.
Absolutely. Absolutely. So I don't think we have any open questions.
Okay, there is one question just came. How often we will have doubt clearing sessions? So yes, doubt clearing again will depend on the way the course goes. For example, if learners would like to have doubt clearing, say every week, so there will be, if they like, this is completely manageable by the instructor or instructors and learners. It's not fixed. And therefore, they will, in fact, when you have a discussion with each other, that during early interaction session, everything, first week or 2 weeks, that will be clarified and then will be decided. So it goes according to the convenience of both sides, but definitely not a single doubt that you have will remain unanswered. That I can assure on behalf of everybody. And in fact, we would love to hear the doubts that in itself also gives the boost to the learning. So yeah, that's not a problem. And TS also will be, of course, involved. Yes.
May I add something to this? Actually, we are talking about a lot about the interaction between the faculty and the students and among the students themselves. So we do have a LMS system. So maybe Simplilearn colleagues could actually throw some light on this aspect.
Oh, thank you, Anil, for that. Yes, yes, that's a good point. Yeah, yeah. Would you, anybody from Simplilearn would like to talk about that?
Dinesh, if you can highlight how our LMS is structured and what the students would be able to access. Yeah.
Yeah. So, Simplilearn LMS will be able to give access to the recorded lectures, as well as there'll be a schedule based on the confirmation from professors, where the students will be able to register for the live class or for the tutorials. And the LMS will have the facility to take the quizzes, and they'll be able to submit the projects, and they'll be able to take the online exams. And also LMS will be having feature to grade all the submissions, either it can be quiz or it can be projects or it can be exam. And the final transcript of the students will be submitted to the IIT Bombay. So that's how.
I think there is also the option of having a forum where the students can post their questions. I think Professor Anil was trying to reach here with respect to that, so that the TS or instructor, depending on how they manage that, they will put answers over there. That is also one way. I think that is what Professor Anil was trying to mention.
Yes,
right?
so there is a community Slack channel we will be using for all the students for the respective courses. and professors, TAs, and our learner success manager. So everyone along with the students will be part of that community channel, and any real-time communication can be happened through that Slack channel, and students can ask queries, TAs can answer, or if professors are available, they can also answer. So that's the real-time community channel that we are having as part of our LMS.
I think there will be some training also for learners, right? For
Yes,
an
Prof.
LMS. Okay.
So the team will be giving the complete LMS walkthrough during the induction session. So that's the session we spoke about during our schedule, where August 22nd, which is the first induction session, and all the learners will be taken through the complete LMS walkthrough, how to access the course, how to see the channel, or how to use the community channel, and how to take the quizzes, or how to submit the documents. So everything will be given a complete demo during the induction session.
Great. Thanks, Dinesh, for
Thank you.
Thank you, Dinesh. So just to take a pause before we have some last minute questions, it's a request to learners who are interested in being a part of our very esteemed program. If you can just select a yes or a no on the poll that I'm about to launch on Zoom, you will see an option yes or a no. So yes would mean that you would be contacted by our learning advisors who will help you understand all the details. If you have any questions to ask them, you will be reached out by them tomorrow morning. Yeah. So if you select a yes, means that they would call you, and yeah, great.
There is also a request, from Rishabh, I think, the last.
Yeah.
one. Yeah, so requesting to provide timely future updates regarding this program. So I think,
yeah.
yes, I think it's Simplilearn can continuously update. Yes.
Absolutely. So if you want to attend more such events or more such webinars, please request you to kind of mark Simplilearn webinars. This idea is important, or just email us at webinars@simplilearn.net. I think my screen is shared, so I'll just quickly show you the email ID.
And also, I think, Aparna, if there is a way that in general you can, provide some generic updates. Suppose if there are public domain updates for everybody regarding this ePGD, so you may post it on social media or any other channel you have been using for everybody. So I think that also would be useful.
Absolutely. I think that's a great suggestion. We'll keep this in mind as well. Yeah, definitely. I think that will help the learners, will also be able to reach a wide range of learners, and of course, help the learners gain more clarity about the course. So we also have a compliment from one of our learners here who says that thanks for answering all the questions, professors. I think it was a great launch webinar, marks the start of a great program as well. So I'd just like to request to the professors just to give some closing thoughts to the learners here, and motivate them to kind of take the right step, what they can do next in their career. Yeah. Professor Maryam, if you can kind of.
Yeah, so first of all, best wishes for everybody here. And the second, I thank really my colleagues, EO team and Simplilearn team for providing eventually this opportunity to really have live interaction with you. I'm sure that I talk on behalf of my colleagues. We love interaction with the students and interaction with learners and those who want really learn. And with respect to particular this ePGD, really it has been designed to become a kind of not lengthy, not too short, not small, not too big, and eventually a kind of optimal design. So we have designed a course as we design a second, so that a set of courses which will give a reasonable time to working professionals, fresh graduates, and anybody who would like to learn IC design. Hopefully, those who are interested and join together, all of us, we would be able to really make it successful, and you will get benefited out of it. And as I told you, just because this is in addition to the work that all colleagues have already load in the department. Therefore, this is really a great work by all of them. And having their experience and their teaching and being a faculty in the Department of Electrical Engineering, IIT Bombay, all of them. So I think they are spending time on this to make hopefully that successful, and the real success will come if you see that you have learned well and you yourself contribute to the class. You know, the class goes well if you contribute. If you become a person who actually will be able to manage the course along with others, you conduct the course, in fact, and therefore faculty will be along with you. So that even will save more time from faculty as well. I don't have any other thing, just to advise everybody, whatever you do, you try to learn well. And always I say we should have deep learning for our own natural intelligence. Rest will come anyway.
Absolutely. Great closing thoughts. Professor Anil, Professor Dinesh, Professor Lakshmi Shah have closing thoughts as well.
And I also got new aspects, new dimensions even today from colleagues from the device as well as the design. Yeah, thank you. Thank you all, really. Yeah, thank you. I don't have any other.
Bye.
Oh, Professor Sharma, good to see you. Yes. One thing I have to mention that really it's privilege. Professor Sharma is actually the teacher for all of us. And therefore, I think you will be benefited having two courses. Eventually, he is a part of it.
Thanks,
And,
ma'am.
yeah.
In fact, one stray thought that I had was that surprisingly, our experience during the COVID times has helped us a lot, and we are all not new to this mode of teaching, and we have had experience interacting with relatively large classes actually for teaching our regular courses. And this actually includes some of the lab courses that we conducted, and we will also learn as we go along and gain experience from this mode of teaching.
Yes, true. Yeah, that's true, Professor Sharma. Yeah. Yani, the COVID experience really was a learning for all of us. Yes, thank you for mentioning that. And that has helped us to really see how we can manage this kind of mode of outreach activity. And yeah, hopefully now. And as he mentioned, even who knows, maybe tomorrow, later, some specific labs in the CEP mode, maybe may not be in ePGD mode, but CEP mode, as Professor Usha mentioned, can be conducted. Yes.
Yeah, this is Anil.
Yes.
I just want to make one remark that we have this is a design-centric course, but always it's very important how the people who are doing the design develop strong foundations in how the devices operate, and what is the model, what is the basic behind the fundamentals behind the compact models that are used for design of the circuits, and how they are made. So that actually gives you a well-rounded education, which basically would help you to make better designs. And also when you actually make these devices, a lot of interactions happen between the designers and the technology people who actually make these devices. So you would be better equipped to engage in this kind of interactions in any organization that you work, and that would be a major asset. In fact, that is the reason why we are including the device aspects, the fabrication aspects in this particular course. Thank you.
Yeah, thank you, Professor Anil. Yeah, really, I mean, he referred to a very important point. Somebody who is IC designers at the same time knows about the device aspects and the device models and today's technology will be really a good IC designer. Yeah, thank you, Professor Anil. Really, it's a very important core course. That's why we have kept the device also as a core course for everybody. Yeah. Okay, good. Thank you for all comments, and thank you. The last comment as well, which is like a kind of paragraph. And yeah, wish you all the best.
Yeah.
Nav
Girvani, yeah,
Nav
it's
Girvani.
their
Yes.
email IDs, so we can't really make out what their
Oh,
names are.
Girvani.
Yeah, yeah. But anyway, it was great.
Yeah.
Great comment. Thank you, learners, for also, taking part in this very, very interesting session. I think, yeah, Girvani, yes. Thank you so much.
Okay, Girvani. Yes.
Right. Thank you, Akhil. Thank you to all the learners. Kashyap, Dinesh, would you like to add what Professor said?
I think nothing to add from my side. I would just like to take the opportunity on behalf of all the learners to thank all the professors for taking time out from their busy schedules and helping address even the smallest of questions that have come up from everybody considering this program. So Professor Maryam, Professor Anil, I think Professor Lakshmisha, Professor Dinesh, and Dr. Satatru, I think all of you, thank you so
And
much.
Professor Sandeep.
Very helpful. And Professor Sandeep, so sorry.
Yeah. Thank you, Kashyap. Thank you, Dr. Satatru, and thank you, Aparna, for the moderation and nice event interaction with the learners.
Absolutely.
Yeah.
Absolutely. I'm sure the learners also kind of have the same comments. The learners, it'll help if you kind of just, those reactions are actually proof to that. But great, great. Thank you, professors. Thank you, Dr.
Thank you. Thanks,
Thank you.
everyone.
Thank
All the
you.
best for all of you.
Yeah.
Thank you. Bye.
Bye.